Chapter 12, Lesson 7 on the surface area of pyramids and cones. Okay, so the first thing is that when we talk about surface area of pyramids, we're going to be looking only at regular pyramids. And a regular pyramid is a pyramid whose base is a regular polygon. So that could be, for example, a square. It could be an equilateral triangle. It could be a regular hexagon. It can have any amount of sides, but they all have to be equal and the angles have to be equal. Okay? When we talk about a regular pyramid, a pyramid in general, we also talk about something that we call the slant height. And we've talked about the height of the pyramid, and the height of the pyramid goes from the top, the vertex up here, straight down to the middle of the base, right? So let's remember what we call things, right? Down here at the bottom, we have the base of our pyramid. Here we have a lateral face. Here we have the vertex, okay? And then this line that I've drawn in yellow is what we call the slant height. And it is the altitude or the height of each lateral face. So think about just this triangle here that's in the front, this lateral face, the height of that triangle. The height of the entire pyramid, remember, also starts at the vertex, but it goes perpendicular right down to the middle of the base. The slant height goes down the side of the pyramid, perpendicular to the base. Okay, so when I need to find the lateral area of a pyramid, the lateral area would be the area of all of those triangles around the outside, and there might be a different number of them. So what I do is, because the area formula for a triangle is 1/2 base times height, I take 1/2 of the perimeter of the base times the slant height. So this is the perimeter of the base, and then this cursive L is the slant height. And that's how we find the area of all of those triangles. We don't have to do them individually. So to find the surface area of a pyramid, I'm going to take the lateral area plus the base, all right, the area of the base. So the surface area, we can write that as 1/2 the perimeter times the lateral area plus the base. And this is the area of the base, and that base could be, remember, a square, a triangle, a hexagon, a pentagon, any different shape. Okay? Now, when we talk about the lateral area of cones, if we think about if we took a cone apart, right? So we have a cone, we have the base of it, we have the radius of that, and then the slant height is going straight down the edge of the cone. If I took a cone apart, I'm going to be left with this circle that was on the top of it, kind of like the empty place on the ice cream cone where we'd put the scoop. And then we have this kind of weird shaped triangle with a curved edge. So we have kind of a funny formula that helps us to find the lateral area of our cone. And that formula is that we do pi r L. So we do 3.14 for pi. This is the radius of that base, and this is the slant height. And that's how we get the lateral area of our cone. Then to find the surface area of the cone, we do, obviously, the lateral area plus the area of the base. And so if I want to show what those are, the lateral area is pi r slant height plus, and how do we find the area of the base? It's a circle, so we do pi r squared. Okay, so let's do one example together. We have a pyramid here, and we need to find the lateral and the surface area. So let's find the lateral area first. So remember, our formula is 1/2 perimeter times the slant height. So our lateral area is going to be 1/2 times, well, the perimeter of the base is a square, so 10 times 4 is 40, times the slant height, just the height of that face of that triangle. So my height comes right down here, and it's labeled as 9. So I'm going to do the lateral area is 180 centimeters squared. And then to find the surface area, I'm going to do that lateral area, which is 180, plus the area of the base, and it's a square, so I'm going to do 10 times 10, which is 100. So my total surface area is 280 centimeters squared.